Guys, welcome to Sciencing Around and happy sciencing and welcome to this next part of the current electricity that is nothing but the electric cell. Now, if you're finding about the annotations of these cells in series and parallel and all that stuff, you're watching the right video. And if you're watching the Kirchhoff's rules, then I'll be making it in some other video because it doesn't need theory part, it needs problem solving. So what is electric cell? Electromotive force is the voltage of the electric cell when it's applied in an open circuit. Its internal resistance is the resistance offered by that cell itself and depends on area of the plate, distance between the electrodes, and strength of electrolyte and the temperature. What is terminal potential difference? It is nothing but V equals to electromotive force minus the current into its internal resistance and nothing else. In usual cells, the I, that is current, moves from cathode to anode, but in charging cell it moves from anode to cathode, and while charging, potential energy across its terminals is greater than its EMF. Why it's potential energy? It's actually potential difference. So terminal potential difference equals to V equals to E plus IR while charging. So when E is EMF, that is electromotive force, R is internal resistance, and capital R is external resistance, R is not equal to 0 or infinite, then I equals to E upon R plus R by simply applying the formula I equals to V by R, where V is E and R is R plus R. Nothing else. Because what is an external cell? Now let me draw you a simple diagram for a cell. It's a cell. Alright. This is his plus, this is his minus. We have here this thing. And don't forget we have a small amount of resistance inside the cell. This is the internal part of the cell, and this resistance is the internal resistance, and this voltage is the EMF and nothing else. Now power transferred, we know power equals to I square R, that is V square by R. That is nothing but E square upon R plus R the whole square divided by R, that is E square R upon R plus R the whole square. Capital R plus small r the whole square, that is E square into capital R, that is E square into external resistance upon external plus internal resistance the whole square and nothing else. Power transfer is maximum when external resistance equals the internal resistance, and which is equal to E square upon 4R. And now let's get down to the connections of the cells, that is cells in series first. First, whenever the cells are in series, you can see the diagram right here. Net electromotive force equals to Ne, where N is number of cells, and total resistance is R plus N times R, that is product of the total number of cells into its internal resistance. Now current is, we know V by R, that is Ne upon R plus NR. As we know these two, we can just calculate the current. Two cells of different electromotive forces, simply sum that electromotive forces and the internal resistances. We know I equals to V by R. Total electromotive force is the summation of electromotive forces. Total internal resistance is summation of that internal resistance and nothing else. If one cell is reversed, then I equals to E1 minus E2, because E2 is reversed, so its electromotive force would become negative. So E1 minus E2 upon, but resistance would always become positive, that is R plus R1 plus R2. Now nothing else to explain right now. Let's get on to our next page, shall we? Now what is this? If total cells if there are totally n number of cells which are wrongly connected, then that means oppositely corrected, we can say, the net EMF would become n minus 2n, that is the total number of cells minus 2 times the wrongly connected cells into its electromotive force. Another motherfucking formula, right? No ways, come on. I equals to n minus 2n into E upon R plus NR. We know I equals to V by R because V is this, R plus simply R plus NR, no change in internal resistance because it cannot be negative or positive or something. No, sorry, it can be positive but not negative. Now we have cells in parallel. Now let net EMF is E, net internal resistance is R by M. M is number of cells. So in parallel we can see in this diagram total resistance is R by M, where M is number of cells. So total resistance is R plus R by M, where R is the external resistance and current is E upon R plus R by M, V by R. If n cells of different EMF, as you can see here, if n cells of different electromotive force, then EEQ equals to E1 upon R1 plus E2 upon R2 plus EN upon Rn upon the summation of all the internal resistances. And we can now see 1 upon Req equals to summation of 1 upon R. That is the internal resistance, finding equivalent internal resistance, no doubts, just as the resistance is in parallel. I equals to Eq upon Req plus R. Find this, where is find the internal resistance. You can see right here, find this thing, divide this all V by R, you can get the current. Now what is mixed grouping? If m rows of n cells, okay, now number of rows are m, total cells are n. That means total cells would become m times n. EMF is E and R is internal resistance, then current equals to m times n times E upon mr plus nr. I don't think that's quite important. If you have just learned the formula, then okay. If you didn't, don't quite pay attention to this thing. Now maximum current is obtained when mr equals to nr. Again, that thing, I won't go to Kirchhoff's voltage law, just say summation of the voltage plus summation of the EMF equals to 0. That is summation of IR, that is I1R1 plus I2R2 plus dot 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 I1Rn, that is I1R1 plus I2R2 plus dot 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 plus INRN plus E1 plus E2 plus En equals 0 and nothing else. Maximum power theorem, power equals to electromotive force square into R upon R plus R the whole square, as I just told it right behind. And for power to be maximum, I told it right now. Now Jules heating effect, work equals to I square, work equals to I square RT, and H is heat is I square RT upon J, where J is 4.18, J is the value. So Jules effect is irreversible. We know what is electric power, V square by R. Electric power equals to I square R. I square R or V square divided by R, where VA is applied voltage, VR is rated voltage. Okay, VA is the voltage that we apply, VR is the rated voltage, then power consumption is what? VA square upon R. We know that P dash equals to VA square upon R equals to VA upon VR the whole square into the PR. And resistance is V square upon R. We know power equals to V square by R, so resistance equals to V square upon power. In series resistor, connection is same, P1R2 plus P2R1, because in series the power is directly proportional to its resistance, and in parallel the power is inversely proportional to resistance. Now PP upon PS equals to N square. Consumption, now it's a very important topic to be right here. Consumption of electrical energy. Bohr trade units. Now it may be asked in any MCQ. It can be asked in any of the MCQs or any of the other exams, that what is the actual value of the Bohr trade unit? Then you can answer 36 into 10 power 5 kilowatts per hour. Units of electrical energy consumed is number of watts into number of hours, that is number of watts into number of hours divided by 1000, that is kilowatts per hour. Number of watts, the electrical power, that is I square R. Number of hours it's being used upon 1000. We'll solve the problems on it next time, but right now theory part. Now an important part, that is the Wheatstone's bridge. Here I1R1 equals to I2R2. What is I1 now? We have a lot of space here, right? Now let me draw one. So guys, here's the diagram. You can see right here the voltage, that is the plus and minus sign. This is R1, current flowing through it is I1. This is R2, current flowing through it is I2. This is R3, current flowing through it is I3, and this is R4 with current I4. So what does this say? I1 is I3, then means I1 and I3 are equal, and having the value of V by R, that is epsilon, that is electromotive force upon R1 plus R3. And I1 and I2 and I4 are equal, having the value of electromotive force divided by R2 plus R4, that is divided by R2 plus R4. And another equation we get, that is R1 upon R1 plus R3, that is R1 upon R1 plus R3 equals to R2 upon R2 plus R4. And of course R1 upon, by this we can say R1 upon R2 equals to R3 upon R4. R1 upon R2 equals to R3 divided by R4. The ratio of these resistances are the same. And one more thing, this G thing. Now I just placed the G here because let the G value be 1 ohms, or let 10 power 30 ohms. it won't give a fuck. So guys, I hope that was okay for now. We have completed with current electricity. Kirchhoff's rules, I'll just explain it some other video because it needs problem solving. I'll definitely do that, I promise. And guys, please tell me how was my video in the comment box. I would definitely respond to you and would try to improve myself as per your comments. So guys, see you soon. Right now, goodbye.